So this is a quick review of adding and subtracting fractions, an extension into adding and subtracting fractions when they involve variables. So first I want to look at a quick problem. This video does assume that you are familiar with adding and subtracting fractions in the process of doing that. So if you need a review on that, you can go ahead back to the video lesson that talks about adding and subtracting fractions, both with like denominators and the one with unlike denominators. But we're going to assume that you know how to do that. So here, in this case, the first thing we have to do is recognize that our two fractions don't have the same denominator. The left-hand fraction has a denominator of 20, and the right-hand fraction has a denominator of 5. In order to add or subtract fractions, we have to create one with the same denominator. In this case, our common denominator that we're going to find is probably going to be 20. So we can transform the fraction on the right by multiplying numerator and denominator both by 4 to get 17/20, still for the left fraction, plus 12/20, which is the same as 3/5, or just a different representation of it. Then we can add across the numerators because we have the same denominator to get 29, and the denominators will stay the same, so our final answer here will be 29/20. That is the sum of 17/20 and 3/5. We could transform it into an improper, rather it is an improper fraction. We could transform it into a mixed number if we wanted to, but we really don't need to at this point. So, the most important thing that we talked about when we said that we were adding and subtracting fractions without variables is that you need to find a common denominator for the fractions. Well, the same thing is going to be true of fractions when you have variables. In order to add or subtract them, you need to find a common denominator for the fractions. Now, the ones we're going to look at now are just ones where the variables are going to be in the numerator. You can find common denominators because we can find least common multiples if there are variables in the denominator. We're just looking at ones where the variable is in the numerator. So let's take a look at one of those types of fractions. Then we're going to look at one that has the same denominator in both cases because that's how we started. We have 2x over 7 plus 3x over 7. Now if we followed that same process that we'd had with fractions that didn't have variables, then we would just add the numerators. 2x plus 3x is 5x. And then the denominator stays the same. So our old process should give us an answer of 5x divided by 7, or 5x over 7, however you want to say it. Let's look at another example to see if that same kind of process would work for us again. Here we have two other fractions, also with the same denominator. 9 is the same in this case. Our left-hand fraction has 2x as a numerator, and our right-hand one has 5 as a numerator. Now these aren't like terms. If we just gave the expression 2x plus 5, we could not combine that in any way to make it any simpler than it is. So if we're going to follow that idea where we add across the numerators of the fractions, the best we can do is make it 2x plus 5. The denominator will stay the same. So our old process would give us 2x plus 5 over 9. And so far, that same process of adding and subtracting fractions seems to be working well for us, so let's go ahead and see one more example here. In this one, we have two different denominators. We have 3x over 5 and x over 4. Now, the least common denominator we can find between 5 and 4 is 20. So go ahead and pause the video, see what you can do about transforming these fractions to a common denominator of 20. See what you get when you add them together. Remember, you may have to worry about combining like terms, and then unpause the video when you're ready to go through the answer here. Well, to find a common denominator of 20, we need to multiply our left fraction by 4 over 4, and we need to multiply our right fraction by 5 over 5. And so we end up with 12x, because 3 times 4 is 12, and the x is just the same, over 20. And we have, for the fraction on the right, 5 times x is 5x. And 5 times 4 is 20. So now we can just add the numerators like we had before, 12x plus 5x. We can combine those like terms. That is 17x. And then the denominator is just going to be 20. Because the denominator always stays the same when we add. And it turns out that this process that we've been going through, just using our familiar find a common denominator, add or subtract the numerators as necessary, or as indicated by the sign, and then keep the denominator is actually what we're going to do when we have fractions with variables. First, we find a common denominator because all fractions need common denominators when we add or subtract them. Then we're just going to follow that same process, adding or subtracting them just like normal. But the thing we have to look out for is that in the numerator, we may have to worry about combining like terms. Either in the case where we can add the two terms together, or in the one where we have, such as the 2x and the 5, where we can't combine the terms. And remember, we can only combine terms if they are like two x's with each other, two numbers with each other, which remember we call constants. And so we've got 6 practice problems here for you to work on. Go ahead, pause the video, see what you can do about these 2 problems first, and then unpause the video when you're ready to go through those answers and move on. So here in this case, we don't have any change that we need to make with the fractions to find the denominators, so we just add or subtract the numerators. The first one is a subtraction, so the numerator becomes 3 minus x, and the denominator becomes 5. So we get 3 minus x over 5. On the right-hand fraction, we also have the same denominators, so 2x plus 7x in the numerator is 9x. The denominator stays the same at 13, so our final fraction for the addition of those two is 9x over 13. Here are the next 2 problems for you to work on. Go ahead, pause the video, see what you can do with these, and come back when you're ready to move on to the answers. So in the left-hand fractions, our least common denominator is going to be 12. So we need to multiply by 3 in the left fraction to get 27 over 12, or rather by 3 over 3. In the right-hand fraction, we need to multiply by 2. So we have plus 2x over 12, and then we just add the numerators together. 27 plus 2x is, well, just 27 plus 2x. And the denominator stays 12. So our final fraction is actually 27 plus 2x all over 12. In the right-hand example here, the 4th one we're looking at, the least common denominator between 5 and 11 is 55, which is 5 times 11. So multiply the left-hand fraction by 11 in numerator and denominator, get 11x over 55. In the right-hand fraction, we'll need to multiply by 5 in numerator and denominator, get 5x over 55. And then we just subtract the numerators like normal. 11x minus 5x is 6x. And that is all over 55. So we get 6x over 55. And for our last 2 problems, go ahead, pause the video, see what you can do, and then we will go over the answers when you unpause the video. So we have in the left-hand fraction, we have a 7 and 3. Our least common denominator is going to be 21. So multiply the fraction on the left by 3 over 3. Multiply the fraction on the right by 7 over 7. For the first one, 3 times 3y is 9y over 21. The fraction on the right becomes 14 over 21. And so our final answer here is going to be adding the numerators to get 9y plus 14 all over that same denominator, which is 21. And then finally, our last one in the right hand fraction, x over 12 is what it is, because 12 is going to be that least common denominator. On the right-hand side, we have to multiply by 4 over 4. And we get minus 8x over 12. X minus 8x, remember we can have negative coefficients with variables, so that becomes negative 7x. And all over 12. So negative 7x over 12 is our final answer there. So just a brief reminder that when you add or subtract with fractions with variables, you follow the exact same process as you do for fractions that don't have variables. We just have to be aware that we might have to worry about combining like terms, either with just adding or subtracting as it is, or keeping 2 terms separate, such as that first example with 2x plus 5 when we can't combine unlike terms.